After getting some quotes for a simple water heater swap, I will be changing out my old electric water heater. This water heater is about 20 years old and past its prime, as we can see from the water stains at the base and the corrosion on the outside of the tank. For this installation, we had to get a little creative as we ran into a few challenges due to the water heater's location. Also, we will be installing a new quarter-turn valve, expansion tank, and bringing everything up to code. Be sure to stick around till the end to see what we find in this old water heater. This house was not blessed with a large utility closet, so we will have to make do with the space we have. Before we start, we'll measure the diameter of the existing water heater to ensure the new one will fit. This will hopefully prevent multiple trips to the hardware store. Now that we have a unit that will fit, we'll start by cutting the power by using the timer box, which has a cutoff switch. Alternatively, we could cut the power at the breaker box. Next, we'll drain the tank by first closing the water valve to the water supply. And of course, nothing is ever easy. The valve is corroded and won't turn, so we will need to cut off the water at the main cutoff valve. Now we can hook up a garden hose to the drain spigot and start to drain the heater. Some spigots will need a screwdriver to open. To prevent pressure from building up and to properly drain the tank, I will also open up the hot side to a nearby faucet. I opted to run the water out to the grass in the front yard. Another option is to just run the hose to the nearest drain. The water is likely still going to be hot, so don't touch. It should take a few minutes for the tank to drain out. While the tank is draining, we'll move on to disconnecting the electrical wires. We'll remove the cover, then test for voltage before diving in. Next, we'll unscrew the wire nuts and separate the wires. And lastly, we'll unscrew the ground wire from the water heater. Next, we'll loosen this metal collar, and I'll be sure to keep this piece because I am unsure if the new unit has one. Now we can pull out the wires. On to the connector hoses. These Craftsman self-adjusting pliers seem like a good idea, but on the second connector that was a little corroded, I was unable to get it off. I eventually switched over to the tried and true crescent wrench. Since we plan to replace the corroded water valve, we might as well replace the connector hoses. Whenever removing a fitting from another pipe, it is always a good idea to grasp the other pipe with a wrench to prevent flexing and twisting. After removing this last hose, we have one more thing to disconnect. This is the pressure relief valve, and the line it is connected to goes somewhere outside the house. Funny, some of the stuff you'll see in an older home. Not sure this setup meets today's standard, so for our new setup, we plan on doing something a little different for the pressure relief valve. We'll also be taking off this valve to allow for more clearance. This job would be much easier in a large utility closet, though I can't complain too much, at least it's not in the attic. The tank should now be empty, so we can unthread the water hose from the spigot. Now there should be no more connections to the water heater. We should just be able to pop this thing out. And of course, we run into another obstacle. This water heater is bumping into the timer box. We'll cut the power at the breaker box so we can safely move it. Just a couple screws need to be taken out, and then we'll hang the box above the tank with a wire hanger. To be on the safe side, we'll also jerry-rig some cinder blocks, which were just a couple inches higher than the height of those AC condensing lines. We'll also secure the blocks with some 2x4s screwed into the wall. We used the block as a pivot point to lift the tank and ensure the condensing lines would be protected as we move the old unit. We probably could have carried this thing out, but why risk a hernia when we have a dolly? They do make dollies specific for moving water heaters, but a regular dolly should work just fine. Even though this old tank was empty, it seemed a little heavy. Later in the video, we cracked this thing open to see what was inside. Looking at a side-by-side comparison, we can see the water heaters are almost the same size. However, the newer unit has much more insulation, and we're gonna end up losing about half the water capacity. However, we should see a reduction in the utility bill because the newer unit is far more efficient. With the tank out of the way, we'll take some time to fix some things up and clean the space. We'll start by changing out the old gate valve for a quarter-turn ball valve so we can turn the water back on to the house. This is not just any old quarter-turn valve, but a high-quality brass Italian ball valve. We are wrapping Teflon tape around the threads to help seal the connection. When using Teflon tape, you'll want to wrap the tape around the threads clockwise when looking directly at the pipe. I like to do 3 to 4 rotations with the tape. We'll also be using pipe dope around the threads. Some people say to either use Teflon tape or pipe dope, but A little dope won't hurt. When we secure on the new valve, it will not unwrap the tape because we are turning in the same direction the tape has been wrapped. I seriously do not like those gate valves. These quarter turns are far superior, and this valve in particular should last a very long time. With the new valve installed, we can turn the water back onto the house. These pipes were also not very secure, which can cause rattling. We will be adding some blocking and straps to tie down these pipes. First, we'll locate a couple of studs behind the wall. I had a scrap 2x4 laying around that should work fine as backing. We will be using these copper straps to secure the pipes. Since these pipes are copper, either the same metal straps or a similar alloy like brass will need to be used to prevent bimetallic corrosion, also known as galvanic corrosion. This is not a science channel, so if you want to know why that occurs, please consult the interweb. These pipes shouldn't be going anywhere now. While we still have easy access to these pipes, we'll use some pipe insulation on the hot water supply line. This stuff reminds me of those pool noodles that you'd use to beat each other as kids with. We'll cut some insulation from the back to account for the 2x4 blocking. Then cut the excess off at the bottom and then secure the insulation by wrapping it with some aluminum tape. The old unit was sitting on a piece of 3/4 inch plywood which had a number of stains. Before we can remove the plywood, we needed to chisel out some mastic that was used from the HVAC install. With this piece removed, we might as well sand and paint the floor as well. With the floor and plywood painted and freshened up, we are getting closer to installing the new unit. And for those with OCD, don't worry, we ended up painting the 2x4. With such a small space, we are using this plastic drain pan because it has some flexibility to better fit the area. Though these tanks aren't extremely heavy, they are somewhat unwieldy. Our install was a little more precarious because of those air conditioning lines.
If you could pick it up this way and and stab it in there, but
okay, come on down. Come on down. All right, we're done now. Okay. With the new tank in place, we'll start on the pressure relief valve. Since we have a drain pan now, we'll measure to cut a copper pipe that extends from the relief valve to the drain pan to direct any water that exits the valve. We'll leave a few inches from the pipe to the bottom of the pan. To cut the pipe, we are using this old pipe cutter from the old man's toolbox. This little thing also has a deburring tool, which should be used after cutting pipe. A burr can disrupt the flow of water and cause turbulence, though this part of the water heater hopefully will not see a lot of water. It is still good practice to prep your pipe. After roughing up the surface of the pipe and the inside of the fitting with some emery cloth, we'll apply some flux. This will also be the only thing we solder in this project. We'll use a small torch to heat the fitting and the pipe. As it heats up, we'll test to see if we are at temp by poking it with the solder. Once the solder melts, we'll feed a little bit into the joint. It's easy to add too much solder, which can cause it to drip on the inside of the pipe, which is not the end of the world, but not ideal either. We clean up the solder joint by following up with a cotton rag. Just be sure not to use a damp rag. We'll add some Teflon tape before tightening onto the relief valve. This water heater also came with some insulation that goes around this valve. We also had some extra pool noodle laying around, so we wrapped it around the pipe. In order to comply with code, we'll need to add this thermal expansion tank. These devices help regulate spikes in water pressure caused by heating. We'll be using these threaded fittings to secure it to the water heater. First, we will do a dry fit to see if we have the right fittings. And this looks pretty good. Let's tighten everything up with some T-tape and dope. Every DIYer needs a good set of pipe wrenches. These fittings do not have hex sides for a traditional wrench. All of these threaded fittings are tapered, which means that the top of the male fittings are ever so slightly smaller at the tip and slightly wider at the base. And for the female ends, the inside gradually narrows. Obviously, as you thread them together, it becomes more difficult to tighten, which is why it is important to have a nice sized wrench for leverage. Even though the fittings are tapered, it is sometimes difficult to achieve a watertight seal, which is why we add Teflon tape and pipe dope. This last nipple fitting did have a hex side for a traditional wrench. Another nipple fitting will need to be added to the quarter turn valve in preparation for the connector hoses. All of the fittings and connector hoses we used in this project were 3/4 inch in diameter. Before we thread the fittings for the expansion tank, I want to point out something important. This plastic cover right here needs to come off. However, the plastic piece on the inside of this fitting needs to stay. In fact, what looks like pipes protruding from the water heater are actually called dielectric nipples, and some water heaters come nippleless and need to be added. They simply thread into the tank, which is why you want to secure them with a pipe wrench when you thread another fitting onto it. For the connector hoses, we opted for these nice, shiny copper flex hose, which requires some persuasion to get to the desired shape. There are also braided connector lines that do not require shaping. Also, for these fittings, we did not tighten as much as the other fittings. Unlike the threaded fittings from earlier that taper, the fittings on the end of these hoses have a rubber gasket, so we don't want to over tighten, which could potentially damage them. Once we open the water line back up, we will watch for leaks and tighten some more if necessary. You might have noticed we did not use Teflon tape with the connector hoses. We certainly could have, we just did not find it necessary since the rubber gasket is providing the watertight seal instead of the threads. Before we move on to the thermal expansion tank, these tanks typically come in two sizes, 2 and 4.5 gallons. Which one to use will depend on the size of your water heater. Double check the manufacturer's recommendation before buying. There is a little preparation we need to do before installing. This tank claims to be pre-charged from the factory at 40 psi. However, we need to check to see how much water pressure we have in the house. So we hook up this pressure gauge to a faucet outside and completely open the valve. And wow, would you look at that? Not even 50 psi. The pressure within the tank should be close to the typical water pressure in the home. We'll measure what's in the tank with a tire pressure gauge. Though it is a little lower than the typical water pressure, if we did need to reduce the pressure, we would do so at the valve stem. Conversely, to add pressure, I like to use these little portable air compressors because they have a digital pressure gauge and will add air to your desired pressure. With the expansion tank approximately set to the water pressure of the home, we will add the usual T-tape and dope. Another thing to note is that these tanks can be set in either up or down orientations. We were really only left with the up orientation because of the water heater's location. On to the electrical lines. First, we'll put back the timer box. The cover plate has a metal pop tab that will need to be pressed out so we can feed the power line. Since I want to add this metal collar, these tabs will also need to be removed. This metal collar is not necessary, but I figured since I have one, why not use it? Cutting the ends of the wires so we can strip some fresh copper out of the line. Then we give the tip a little twist. After feeding the power line through, we'll secure the top plate and tighten the metal collar so the power line will stay in place. Time to connect the wires using some wire nuts, starting with the negative black wires, then the positive white and red wires, and finally the green ground wires. Then just tuck these guys into bed and tighten the cover back on. It is extremely important to remember before turning the power back on to the water heater to completely fill the tank so you don't burn out the elements. So let's open our new quarter turn valve to fill the tank. We'll also be on the lookout for any leaks. Similar to when we drain the tank, it is important to open the hot side of a faucet so the air in the lines has somewhere to go. You should hear some hissing as the water moves through the pipes. It also may take some time before the water begins to flow. Let's add a couple more finishing touches. We'll add some pool noodle to the connector hose for the hot water supply line. Adding insulation to any pipe that hot water flows through will obviously help keep the water hot and run more efficiently. Also, we need to connect the drain pan to a drain. Fortunately, there is a vent for the HVAC condensing lines that we can tie into. When cementing PVC together, it is a good idea to twist as you join the two fittings. You may notice a little oopsie from cementing the PVC. If you didn't know, that purple crap is primer, which is applied to PVC before gluing together. It will also stain anything it touches. Honestly, I think I would do this a little differently. Instead of using PVC, which I had to cut in the middle and add a union, a flexible PEX pipe would have been much easier to install. After securing the first half of the drain pipe to the pan, I just need to glue this T-fitting to the vent, but not without getting more purple crap on the freshly painted surface. With the tank completely full of water, we can now turn the power back on to the water heater. Since we are saving money on the labor side of things, we decided to upgrade the type of water heater. This unit has a stainless steel tank which claims to last a lifetime. Curious to see how this thing holds up over time. Let's go see what lies in that old water heater. It was actually pretty easy to disassemble. However, now I am unsure on what to do with this old metal tank. It seems to be nice thick steel that could be used for something. And right before the grinding wheel ran out, I was able to make it through. And man, is that some crusty water. I think a water softener just moved up on my things to do.